Hi everyone, this is just a real quick lesson on graphs of functions. Okay, graphs of functions are the next lesson in your note packet, and this is a really quick lesson. I think you'll pick up on it very quickly. We will of course go over it tomorrow in class, but otherwise I think you should do fine just with these few examples we're going to do here together. This first piece that I'm going to do, I'm just going to give you kind of an overview, and then you'll see when we flip to the next slide that it will match with a page in your notes packet. So for right now, I just want you to watch and follow along. Okay, so we've talked about functions, and functions are a relationship between things where the items in the first group are matched up with items in the second group, but in a way where the first group, each one of those items only gets paired up once with things in that second group. And it's okay if they share partners in that second group, as long as each one only has one partner. Okay, so it's really the domain that matters. Okay, and think about a graph. When you graph something, when you graph a linear equation, or when you graph really anything, what you're really graphing is a set of points, and every point is an xy coordinate, which is a relationship between an x value and a y value. So that's sort of where this ties back into functions, is it's the relationship between the x value and the y value as ordered pairs. Okay, so let me show you an example. Let's say that I have a graph that looks something like this. I don't know if I like that. Let me start that over. I'm going to go a little simpler on you. Something you're familiar with is a curve that looks something like that. Okay, we could have used that previous example, but I didn't want you to get confused. So remember, this really represents a set of points. So this is a point, and this is a point, and this is a point. Okay, and what I want to check is if any of these points, or if there's any x value on this graph that has more than one y coordinate. And the way I do that is with something called the vertical line test, and you're going to see that on the next page as well. Okay, but the vertical line test says that if when I draw a vertical line through my graph, if I only hit one point on the graph, so notice that when I'm drawing those vertical lines, I'm only hitting the blue graph in one spot. If that's the case everywhere on the graph, then this is a function. Okay, this is a function because every vertical line I draw only hits one place on the graph. Okay? On the contrary, if I had a graph that looked something like this, okay, oops, let's just be a continuation of the axis there, and I drew a vertical line, just that one vertical line I'm hitting 1, 2, 3, 4 places. That means that whatever that x value is there, whatever that x value is paired up with 1, 2, 3, 4 different y coordinates. So that would not be a function. Okay, that's the essentials of the vertical line test. So let's take a look at the examples in your notes packet. If you flip to the next page in your notes packet, you should see a page that looks something like this. And you'll see that there are some examples here that kind of illustrate exactly what I was just showing you. So I'm going to wait for just a second in case you need a minute to find this page in your packet. Okay, and I just want us to work through these examples here. So in this first one, if I draw vertical lines, I only hit the graph one time everywhere I draw a vertical line. Now, some people might look at this. I do want to point this out. They might look at areas like this and say, well, hey, isn't that a vertical piece? Like if I were to draw a vertical line right through there, and it's kind of hard to do with this stylus. Yeah, that doesn't look vertical at all, but you get the idea. Wouldn't I hit more than once? Well, I'll tell you right now, these pictures are a little bit oversimplified, but the only way that you could possibly have a vertical portion of your graph is if you have a straight vertical line. A curve like this, like what you're seeing in number 1 here, that's not truly vertical. There is a little bit of a slant to it, even if it doesn't look like it in this picture. Okay, so you wouldn't really hit all of those points. It's kind of tough to tell from the way it's drawn and from my terrible vertical lines. But this, if you look at it, every vertical line is only going to hit in 1 point, so this is a yes. It is a function. Okay, if I look at number 2 and draw my vertical lines, there's nowhere where I could hit more than once, so that is also a yes. Number 3, though, think about that one for a minute. If I draw a vertical line there, or really almost anywhere on this graph, I hit twice, so that's a no, because that means that x-coordinate is paired up more than once. Same thing here. This is very similar to the example I did for you on the previous page. That is also a no, because you hit more than once. And you may get to the point where you don't even have to draw the lines anymore. You can just kind of visualize it. Sorry about that. Hit the wrong button there. So let's look at number 5. Again, vertical lines. There's no place where I hit more than once, so this is a yes. Number 6. No place more than once, so that's a yes. Now number 7. This is a straight vertical line. So if I drew a line right down the center of that line, I hit an infinite number of times because you're hitting all of those points. So this is a no. And then in number 8, also, you'll see that I hit more than once. So that is also a no. So the bottom line is if anywhere on the graph you can draw a vertical line and hit the graph more than one time, then it is not a function. Okay? If every vertical line will only cross your graph once, it is a function. Okay. This next piece, I just wanted to do an example. This is actually out of your textbook, and my picture here is out of the teacher textbook, so you'll see all these answers written in. That doesn't really matter for the purposes of our example here, but you're going to see something similar to this on your homework. I actually was planning on doing the example directly from your homework, but I forgot to bring the paper home with me. I apologize for that. But this is kind of reading graphs and reading the notation with graphs, and this is really, really easy as long as you understand what the notation is asking you. So I'm going to start by taking a look at this first little chunk here, 12 through 16, using this graph. Okay? And this says, let A of t be Alice's weight, and that's important to know, that A of t is Alice's weight at age something, I don't know, I cut off, and B of t be Bill's weight at age t. So this is really a graph of Alice's weight over as compared to their age, and Bill's weight as compared to their age. So what is the range of A? Remember, range of A is like your y values, which are here on your graph. So I want to know for graph A, which is, according to this key, the blue line, what is the range of these values? And you kind of do have to estimate here. In fact, let's see if I can blow this up some. Here we go. The range of A is the lowest point of A to the highest point of A. And I would say, if I had to guess, I would go from about 10 to 140. And I see that the answer actually that they gave here was 8 to 138. It looks like they estimated a little more closely, but I would take anywhere between right about 10 to 140. I'm not going to get super picky about reading these graphs, but so the range again is asking for the y values. Had I asked you for the domain shown on this graph, the domain would be, it looks like, from 0 to 20. okay, because the range is the x values, so I would say this covers x values from 0 to 20. Okay, it says estimate b of 5 from the graph. Okay, so I'm looking right here, estimate b of 5 from the graph. Whoops. So b of 5 means I want to look at the function for Bill. Okay, Bill is the b function. And b of 5 means I want to look at age 5. So right here, if I'm looking at age 5, I hit the graph there. And this is, oh, just a little bit above 40 pounds, maybe 42, 43. Let's see what the textbook says our answer should have been. Yep, 42. Okay, so that's how you would read that off the graph. The b tells you, when it says estimate b of 5, the b tells you which line to look at, and the 5 tells you which x value to look at. Okay, and then you're reading that value off the graph. This last question says, approximate b of 10 minus a of 10. Well, really what that means to do is find Bill's weight at age 10 and Alice's weight at age 10 and subtract them. And it looks like from the graph, if I subtract them, it looks like it's about a difference of 5, which if you read their answer here for that, really what it's saying is that Alice was 5 pounds heavier than Bill, because it appears that Alice's weight is larger. Does that make sense? Let me look at this. Oh yeah. I guess at age 10, which is here, Alice is heavier than Bill. Okay. So those are the types of questions I could ask you from the graph, is really just reading the functions, reading the Alice function, reading the Bill function, and knowing which is which and what they're asking you for. Okay. The other place you might see some notation like that, I'm going to scroll way down to the bottom of this page, is a problem like this one. Now, shrink that back up. Okay, so I've got a table here, and in this table I've got two different functions. I've got the Corvette, and this is what, the value, I believe? Yeah, the value of the Corvette and the value of the Mercedes. So if you look here, they're naming these with function notation. C of x is the value of the Corvette, and m of x is the value of the Mercedes. Now, I don't want you to worry about drawing the graphs, because I think I actually took that one off your homework, but if I were to ask you something like, oh, I don't know, what is C of 1989? What that is asking is, in the year 1989, what is the value of the Corvette? Well, here's 1989, and here's the Corvette value. Okay, so it'd be 18,750. Or I might ask you for M of 1992, which would be the value of the Mercedes in 1992. Okay, so I just wanted to clear up that notation before you jump into your homework for tonight. Okay. So, just a quick recap. Homework tonight is to finish 1-3, which the front of it was homework last night. I want you to go back and do the back. So 1-3B, the back. And then today you should be receiving Lesson Master 1-4B. But I will tell you that we will be doing numbers 4 through 6 together in class tomorrow. So, you know, you may want to give those a try, but if you want to wait, we will do those in class tomorrow. Okay, so again, tomorrow I'll be looking to see that you have finished all of 1-3. You should have gone over answers to 1-3B, the front of it, today. Go back and finish the back, and then Lesson Master 1-4B. There is one on there that's crossed off for you, and 4 through 6 you can skip for now. We'll do them tomorrow together in class. And feel free to email me with any questions. Have a great day. I'll talk to you later.